Well, good morning, everyone, and thank you for joining us for this webinar series for emergency call taking and dispatch. Today's webinar will focus on major event venue and critical infrastructure mapping. We're really appreciative of all who have taken time to come out. As I looked at the numbers, there are people from all across the globe who have registered for this today. So to all parts of the world, thank you for coming in. My name is Mike King, and I am the global manager for the call taking industry, and it's a pleasure to be with you. I also have with me Britt Bromley, who is our partner manager in the public safety space and works specifically with all those partners who deal in emergency call taking and dispatch and the processes throughout that entire industry. I also want to just make mention, we have Brenda Martinez and Ray Umali who are managing this conference or this webinar, and appreciate their efforts. And they may have instruction as we go along if there are any hiccups in what we're doing. Our agenda, as listed here on the screen, will go into immediately a review of major event venues and critical infrastructure mapping. I'll introduce John Brasowski, who will present in just a moment. Following John, we will then be privileged to hear from Craig McCabe of our 3D product engineering team here at Esri, who will share with you a little bit on some of the developments in 3D indoor mapping and navigation that we have. Let me introduce John, and then we'll get started with the conference or webinar. John Brasowski is a Vice President over Innovation for Geocom. Geocom is the only platinum partner on the public safety side of Esri, and has been very strategic in their development of solutions and working very closely with Esri to make sure that they are taking advantage of all of the tools and capabilities that we provide. John has been with Geocom for over 20 years and is responsible for many things. But
unmuted.
Most notable things is he has been in the 911 movement since it began and has provided call mapping and tracking applications that are deployed all across the United States and abroad. Following John's presentation, we'll hear from Craig McCabe. Craig has been using ArcGIS to generate 3D content for more than a decade, and we really appreciate Craig's expertise. I think you'll enjoy seeing some of the things that are happening in 2D and the migration that can occur to 3D and mobile applications. Following each of the presentations, if there are questions that are pertinent or that need to be answered immediately, we'll field those. Brett Bromley will lead that discussion and interrupt as needed, but if not, he'll hold those questions till the end of the conference call. But you will see a number of polls that will pop up during the call today, and we hope that you will participate in those. So with no other delays, let's go right into John's presentation.
Thanks, Mike. Well, as many of you know, Geocom is a 911 and CAD mapping company. Geocom has been in business for over 20 years. We're based in St. Cloud, Minnesota, and we've got 911 and PSAP customers from coast to coast across the United States. And really all we do is GIS for 911. So we provide 911 and CAD mapping applications to PSAPs and emergency responders. We also do 911 and CAD GIS data management solutions. And we also do next generation 911 call routing and location validation systems. So what you see on the screen right now are some common PSAP mapping applications. And as many of you know, a very common workflow in a PSAP is to answer a 911 call. That's what we're looking at in the lower left corner of the screen. Quite commonly, the 911 system equipment at a PSAP will provide the location information for the call to a map, and the caller location will be displayed on the map. And then typically the 911 location information, the caller location information then flows into a computer-aided dispatch system. And of course in the CAD, the call can be further classified based on nature, law, fire, medical, or more specific nature. And then in many cases, the location of the call is also transmitted to in-vehicle mapping and navigation applications that are used by emergency responders. So this is really the current state of 911 location technology today. This has been a success and really has been saving lives for many years. However, it could be better. In recent years, there have been some cases where 911 caller location technology was not accurate or fast enough, and that actually has contributed in some cases to negative and even some tragic outcomes on 911 calls. In fact, a lot of these cases now, when they occur, they make national press, and you may have heard about some of these cases. People, I think, are rightfully beginning to ask why their mobile phone applications, for example, the Uber app that you may have on your phone, seem to have no problems whatsoever determining or pinpointing your precise location when the 911 system cannot. So there's actually a lot of technical reasons for that, but the long story short, the FCC has taken some actions to improve this based on some new technology that's becoming available. The FCC regulates wireless carriers, and of course the carriers are obligated to support 911 for their subscribers. And in the late 1990s and the early 2000s is when the FCC first imposed rules on wireless carriers that required them to calculate location of mobile phones, first cell tower and cell sector location information, and then quickly following that, latitude, longitude coordinates for mobile phones. And the carriers complied. Again, that was in the late 90s and early 2000s. That technology has been a success and has saved many lives in the ensuing years. But again, with the current and newly emerging technology, it could be better. So the FCC has once again imposed some new rules on wireless carriers. And this time around, the new rules will, for the first time ever, require carriers to locate mobile phones that are calling 911. It requires them to locate those mobile phones indoors, including calculation of Z values. And by Z we mean elevation, and elevation could be in the form of indoor dispatchable addresses. An indoor dispatchable address is like a street address, typical building number plus a street name plus a community name, but then also sub-address elements like floor and room, as well as geodetic elevation information, latitude, longitude plus elevation. So these rules that the FCC is imposing to carriers, this transition is going to roll out over a period of years. There was actually a 6-year plan described in the FCC rules, counting from 2015 when the rules were first enacted, and some of the first major milestones actually occurred this year. In order to comply with these new rules, the wireless industry, which includes the nation's leading wireless carriers like AT&T, Sprint, T-Mobile, Verizon, and a number of other carriers, they're working on a system that they call a National Emergency Address Database, or a NEAD. And the purpose of the NEAD is to store for 911 use only locations of wireless access points, as well as Bluetooth low energy beacons that can then be accessed during mobile phone 911 call location determination. So that work is underway even as we speak, but the carriers are not the only ones working on this problem. In fact, last year, Google announced something that they call Emergency Location Service, which they're first making available outside of the United States. And the Emergency Location Service uses the same GPS, Wi-Fi, and cell tower-based position determination technology, or what's commonly referred to as device-based hybrid location. It's the same technology that location services in the Android operating system uses, and that all those great mobile apps that you can put on your phone use. So the intent with the Google Emergency Location Service, again available outside of the United States presently in some countries, is the intent is to make that device-based hybrid location available to PSAPs during an emergency response. In the United States today, there's other companies like, for example, Rapid SOS that are working on 911 standards compliant transmission of device-based hybrid locations to 911 PSAPs. Actually, this location is here today, and as an example, I'm not going to do it right now, but you can go to YouTube and just type in Rapid SOS Geocom Indoor 911, and you can get to a great video that shows this technology in action, actually in a 911 PSAP in the city of Frisco, Texas, where we were mapping 911 calls placed over cellular on mobile phones, actually inside of buildings, which was really a breakthrough in the world of 911. So if you have a chance, I'd encourage everybody to go and check out that video. But, you know, independent of what technology will be used to determine an indoor and 3D location of a 911 caller, one thing is for certain, and that is that soon 911 PSAPs will begin receiving indoor locations for mobile phones that are calling 911. This has an impact on PSAPs, and we'll get to that. But before we do that, we have a poll question for the audience. Okay, so we see that there's still a lot of people that have yet to learn about the new rules that the FCC has imposed on the wireless carriers. So that's great. That's what we're here to talk about today. So back to the presentation. So so the FCC has put these new rules into place requiring 3D and indoor location of mobile phones to be delivered the 911 PSAP. Well, as we regulate, they only remarked at the time that these rules were enacted back along with the College of Science and Engineering at a local university in Minnesota, St. Cloud State University, and Esri, we developed a 3D and indoor map of the SCSU campus, about 100 buildings, and we connected it to a mobile phone caller location application. Then we ran some tests in the campus emergency command center to locate callers with and without this 3D location assisted technology. And really, we wanted to study what it takes to make these kinds of maps, 3D and indoor maps. We wanted to learn about how end users, call takers, dispatchers, and emergency responders could and would utilize these types of maps. And most importantly, we wanted to learn if these types of maps could help. For more information about that, you can go to our website, www.geo-com.com, and on the main page, if you scroll down a little bit, you'll get to a link to a section that's called Indoor Location Mapping. And from there, you can get to a white paper that we published about this early research and innovation project into 3D and indoor location for 911. So, but beyond that early in a live operational and production system that's currently deployed for U.S. Bank Stadium in Minneapolis, Minnesota today. So this system provides a highly detailed 3D and indoor map of the stadium, as well as the immediate surrounding grounds outside of the stadium. And it links it to live feeds from a variety of sensor systems. For example, at the stadium, they have an incident management system, which is just exactly like a computer-aided dispatch system in a PSAP. So they have an incident management system. Then they have a large number of cameras that are inside and outside of the stadium. And then they also have staff that they want to be able to track through the stadium using Bluetooth low energy beacons, many of those that are deployed over 1,000, I believe, throughout the stadium. There's also other sensor feeds that they want to see on the map as well, things like access control to see if doors are locked or unlocked or ajar, and magnetometers and other types of alarms and sensor systems. So this system in operation today is currently being utilized in the Stadium Operations Center, the SOC. It's also being used in the Joint Operations Center, the JOC, and the JOC is manned not for all events, but for certain events. Of course, Joint Operations Center includes Minneapolis PD, Department of Homeland Security, FBI, and some others for very large events. The first operational test of this system was this past July for the 2017 ESPN X Games. It's currently being used during the 2017 NFL season, and it also was used during the Twin Cities Marathon just a couple of weeks ago. Of course, there are more upcoming events in Minneapolis, and including the big one that's coming up, which is Super Bowl 52 next February. So the system itself, it's a custom Esri ArcGIS JavaScript 4.x API web mapping application built by Geocom. You're looking at the application on the left side of the screen. So this is a web mapping application. It's powered by the Esri ArcGIS platform. So the Esri stack that this system uses is what many of you are familiar with and already use within your own enterprises and already have licensing for. It's ArcGIS Enterprise, which comprises ArcGIS Portal, the server, data store, and as well we're using GeoEvent Server. We found that ArcGIS GeoEvent Server was just a fantastic hub, if you will, for centralizing sensor feeds from a variety of different sources. So we could create custom input connectors to lots of different types of sensor feeds, and then sort of standardize them through GeoEvent Server, which would then publish stream services, which could be consumed in our web mapping applications that were powered by the Esri JavaScript API. So GeoEvent Server is really a critical element of this. On the data authoring side, in order to build the maps that we provision in these applications, we used ArcGIS Pro. We also use ArcGIS Online for base maps. And then we also use Drone to Map for ArcGIS to capture some highly detailed 2D ortho imagery in and around the stadium, as well as to create a 3D exterior model of the stadium as well. Just to give you an idea of what this looks like in action, on the left side of the screen is the application running in the Minneapolis Multi-Agency Command Center, which is utilized by Minneapolis Police Department and others. The picture on the left there is from the Twin Cities Medtronic Marathon that just occurred a couple of weeks ago between the city of St. Paul and Minneapolis. And then on the right side of the screen is the application running in the U.S. Bank Stadium Operations Center during a football game at the stadium. So the application itself, to zoom in a little bit, it provides a 3D GIS map of not only the stadium but also the entire city. Of course, the stadium we have the most detail. The 3D building models, the sort of exterior shells of buildings, the sort of translucent shells that you're looking at on the map, those came from TomTom Advanced 3D City models. So TomTom has this type of 3D city map available for many cities across the United States today, and as well as cities outside of the United States as well. The indoor maps for US Bank Stadium came from a variety of sources, including things like AutoCAD, Revit architectural drawings and 3D models, as well as various seating charts and diagrams from the stadium that were digitized into GIS map layers. And then also some ArcGIS map services and GIS data that was provided by the city. For indoor maps, Geocom also uses Micello, who's one of the leading providers of 2D indoor maps today. Another great source of 3D maps, at least the exterior shells, is a company called Precision Lightworks, which is a partner with Eagle View Pictometry. So they've got a system that can take 2D multi-pass aerial oblique imagery, process it through a system, and create really great looking 3D models of buildings. It's really fantastic software. And of course, Esri has something similar with Drone to Map. So we use Drone to Map, for example, before the X Games event in July, to create a 3D map of all of the temporary structures that were erected in the commons area outside of the stadium just before the event. So for the event, as you can imagine, there are lots of vendors that put up temporary structures, and the event itself had lots of structures that were erected just before the event as well. So using Drone to Map, we were able to, in less than a day, really just a couple of hours, fly around the stadium, capture the imagery, process it through Drone to Map, and then provision it all the way up into the mapping application just in a matter of hours. So ArcGIS Drone to Map was just a fantastic product for creating high-resolution 2D aerial imagery that was very up-to-date, as well as 3D surface terrain products for the temporary structures. So here's a full page view of this application so you can see it a little bit better. And the idea here is that as incidents are added into their incident management system, which think of it as their computer-aided dispatch system, you enter an incident in the CAD, and as soon as it's entered in the CAD, the incident automatically appears in a grid underneath the map. And then a dispatcher can click on that location and zoom to it on the map. So here we're looking at a incident on the event level related to a bike valet. We click on it in the grid, and we automatically zoom in on it and the 3D and indoor map of the venue. In addition, there is also a panoramic image survey that of the stadium that we've loaded into the map as well. So this is sort of like a Google Street View except indoors. So you can click anywhere on the map at the location of an incident or where have you, and you can see down in the lower right corner, you can see a panoramic image view that we can expand to see what that location of the stadium looks like. There's also, you'll notice there's camera icons on the map. So we can click on any of these camera icons to see the video feed from that location on the map. I'm not going to open a live camera feed as I'm not connected to the stadium network presently, and also for security reasons. But we found that one of the things that we've discovered operationally was that due to the sheer number of cameras in the stadium, that a map of camera locations combined with a map of incident locations makes it really easy and fast to get to the right camera feed quickly. Otherwise, if you're just looking at an incident location and then you have a tabular list of many hundreds of cameras, it can be difficult to pick exactly the right camera. But using a system like this and the GIS, you can clearly see an incident location. You can see the nearest camera location. You can click on it to get to the feed. Now, if you want to see what things look like on the ground at that location, you can expand the panoramic image survey for the location to see what it looks like. And that's what we're looking at now. This, of course, just like a Google Street View except indoors, we can pan and zoom around inside this panoramic image. So this could be useful when you're planning a tactical response. So, for example, we might stage, if we're entering this section here, we might stage Britt and John over here. We might put Mike around the corner, and we might plan and coordinate our entrance for a particular type of an event. So the panoramic survey, those are static images, not real time. They're captured ahead of time, but it's another way of looking at the the venue and understanding ground truth or what the structure looks like, as well as entrances and access doors, corridors, and things like that, can be very useful in a tactical dispatch situation. And the key is really linking the panoramic images and geographically indexing them, and so that if you click on an incident that's been entered into the incident management system or the CAD, you can automatically queue up or pop open the panoramic image for that particular location. So as we so while this system really focuses on a single venue, of course we know that there's a lot more critical infrastructure in the city of Minneapolis that could be mapped and added to a system like this. So for example, as I'm just sort of flying over the city and zooming in a little bit, we begin to see more detail. Looks like we're getting close to another stadium. And in fact, there are other sports and entertainment venues certainly in the city of Minneapolis. There's venues like Target Field that we're looking at on the map. There's also the Minneapolis Convention Center, and you can probably think of a lot more venues and public spaces that might be useful in a PSAP situation. In fact, that leads to our next question for the audience, the next poll question. Okay, terrific. So looks like there's lots of interest in mapping public schools and hospitals as well. So sort of not a surprise there, but very interesting nonetheless. So we'll advance to the next slide here. So to summarize, we've demonstrated a 3D and indoor mapping common operating picture application. It's capable of 3D and indoor location tracking of incidents and responders, combined with a variety of sensor feeds used for event safety and security. That's all built on the Esri ArcGIS platform. So while this application is event and venue focused, we do see it as a proxy for 911 and CAD PSAP mapping at large. In many ways, a stadium is like a small 911 jurisdiction or a city with a PSAP receiving 3D and indoor locations for emergency calls in CAD, and then being faced with the challenge of locating and responding to those calls quickly and appropriately. So really, the system is all about supporting the mission of protecting life and property before, during, and after large-scale, high-pressure public events. But we do see this as a proxy for what's going on in the 911 world. In fact, the next challenges for us are scaling the system from one building to many. So it's great that we were able to map US Bank Stadium to this level of detail, including indoors. But how do we do it for additional buildings like Minneapolis Convention Center or all of the K-12 schools in the city, or even more than that? So scaling from one building to many is a next challenge for us. And then also more advanced features like beyond just putting dots on the map at the location of an incident, how do we get responders to the scene quickly? And that involves things like indoor routing and navigation. I mean, when I go to US Bank Stadium, especially when I'm not in the public areas of the stadium, it's not easy for me personally to get around. If I have to go to the loading dock, it might be very difficult for me to navigate my way to that location. So I can just imagine emergency responders entering into a building or a venue that they haven't been in before. And for a large enough building or venue, navigating indoors can be quite a challenge. So those are some of the upcoming challenges for us. Thankfully, for Geocom, we partner with Esri, and Esri has lots to say about some of these more advanced requirements for indoor mapping and some of the challenges that we're facing. So, passing it over to Craig.
Great, thank you, John. And again, my name is Craig McCabe, and my focus since joining Esri as a product engineer has been 3D mapping. And over the last several years, that's been a real focus on indoor mapping. And so this obviously has a lot of relevance for emergency response use cases, as these incidents oftentimes occur inside a building. So what are we doing to help our users create indoor maps to locate or route to people or points of interest? I'd like to show you. So in 2017, Esri actually started a new ArcGIS indoors team, and that's to focus on the development of indoor mapping, workflows, tools, and apps. And our goal, a big one of our goals, is this kind of concept of floor awareness, which just means that indoor data layers are treated as a unique layer type in the ArcGIS system. So similar to when you publish a spatiotemporal or like a time-enabled layer, you can use a widget to navigate forward or backward in the timeline. When publishing a floor-aware layer, you should also get some kind of a widget or floor switcher to easily navigate to an area of interest or to a building. And so adding 3D information to floor plans in the data creation process is an important consideration. So once you're Z-enabled, once you have 3D information, you can add in transportation networks, which are also 3D, to better understand movement within and between buildings. So if you start with 3D, 2D just kind of comes along for free. So to make better sense of your indoor environment, whether it's exploring, routing, dashboarding, or conducting field surveys, we're developing apps to help you find your way. So our biggest goal is to empower our users to create and share their own authoritative indoor maps. So what we've done is we've published a collection of data creation workflows and a sample 3D web app that uses the latest JavaScript API. And this sample template you see here, you can download from ArcGIS Online, and it's an ArcGIS Pro project, and it guides you through each step of the process of content creation for indoor maps, and also how to publish those services, configure the map, and deploy the application, this web application that we'll show in a second. So the bit.ly link at the top, bit.ly -indoors 2017 UC, you can go to that link and download this template and also see the app and try it live. So the template contains 4 main parts for creating the scene and these foundational layers for indoor maps. The first part is the CAD to GIS conversion. So we're working on some manual sketching tools as well for scanned floor plans, but CAD is the primary input in most cases. Once you have your data into your GIS, then you create your indoor networks. And these transportation networks are an essential component of an indoor map or a 3D model and can be used to find people or places or equipment inside a building. Next, you can symbolize and publish your 3D GIS layers, your indoor network, for use in the application. And finally, configure the app, set up your floor switcher, your fonts, your labels, your logos, that type of thing. So the first step is just getting the data in. This is a big hurdle for a lot of people. So the latest release of the template, we use a configurable spreadsheet so that you can map your CAD layer names to your GIS attributes and no longer require this kind of firm adherence to AIA layer naming standards. So it's very flexible. And by supplying relative Z information for each floor, when you run the tool, the output features are then 3D enabled. So you essentially get your building footprint polygon, which is the kind of greatest extent of all your floors. You get your floor or level polygons, your units, and your detail lines. So where walls and doors and columns and that type of thing. And so once you have all your kind of GIS data populated, you can either use it to create a 2D map or kind of leverage that Z information, that relative floor level, and create kind of schematic 3D representations of buildings. So once you have all that in the system, next you can build a transportation network. And so this is a mostly automated process, and there are a lot of benefits to creating an indoor network beyond routing. Other network analyses like service areas, vehicle routing problems. Oh, it looks like getting some messages here. Do we have a connection issue? Brenda?
Hi, Craig. We hear you just fine, but can you hit the orange button at the orange arrow at the top? For some reason, we're seeing your panel. I'm not sure why.
Thank you. Sorry about that.
No problem. Thanks.
All right. So, for network, beyond routing, you can do service areas, vehicle routing problems, location allocation, OD cost matrix, and these are all kind of helpful pre-planning tools to optimize the efficiency of a building or its occupants. So routing is the first thing people think of, but once you have a network in place, there's a number of other kind of optimizations and planning workflows you can go through. There are inherent challenges to networks. First of all, they're time-consuming to create. You can't just download your building's network from OpenStreetMap, though maybe someday. Currently, they also require custom applications to consume and display various services or indoor layers. And so there's no out-of-the-box floor-changing widget yet, for example, but we're actually working on these right now, as well as mobile and web apps with dashboard and collector capabilities. And another challenge is indoor positioning, so also known as kind of the blue dot experience. In many ways, just knowing where you are in a building is as important as being able to calculate a route between locations. But depending on your accuracy and your cost requirements, there are many IPS options like Wi-Fi, Bluetooth beacons, which were mentioned earlier, as well as visual light communication or kind of LED lighting, and even magnetic signatures of your building. And so we're testing some of these systems in-house here, so we can provide some recommendations for our users in the future. So the circulatory system of the building, this transportation network, let me go through kind of the process of how we automate a lot of this data creation. And we start with a lattice-based approach. So this is one of our development buildings here in Redlands. And we apply this lattice to the floor, and now we calculate a near distance. So essentially every lattice in this building knows how far it is from a wall. And so we can prefer routes that go down the middle of the hallways, for example. That's where people tend to walk. So you want kind of naturalistic looking paths. We add in all of our network locations. So these are just room centroids. And we use those to pre-calculate along this lattice, this substrate, all the possible pathways inside a building, including pathways to all the exit points on the ground floor. And so what we get then is we have these, three stacks. In this case, we have a 3-floor building. We can connect them up with transition features, so stairs, elevators, other transitions, and then deploy this network. And so for the Esri Redlands example, make sure I don't have a message here. We have, let me just move this. There we go. We have 20-something buildings on the Esri Redlands campus. And what we can do is strip away the building facades. We create all these indoor network data sets, and we can run them in a batch mode, so we can actually create all of these at once. We add our transition features to connect floors together. Then we add in our outdoor pathways to connect all the buildings together. And then we can add in other networks. So we have a parking lot network essentially that extends into every parking space on campus. And so we can actually route from your car, to your office, or even connect up an external street network and essentially have a multimodal network. So we can, dispatch from a fire department directly into an office. So just a sense of how long it takes to calculate this kind of a network. It's about 4 hours of calculation time and another several hours of kind of manual connections and QC. So those are our 3 main buildings. So that said, I want to show you the how this all kind of comes together using the Esri Campus Viewer web app, which comes as part of the template. So I'm going to switch over now. Let's click on the link. So this is a JavaScript web app, runs in a browser using the latest JavaScript API. and this is our Esri Redlands campus. So what we can do is, it's pretty straightforward as far as how you use the application. You can search for people or places, and so you can see there's categorized search options here. And let's say I have a meeting in the M3 North conference room. So I can just type M3 North conference room. Oh, I had it there a second. I'll click on the match. What happens is once I click on that link, the search box, rather the app zooms to our location of interest, removes the textured facade, replaces it with a wireframe, and the room location is highlighted. So now if I want to create a route, I can route from here, and I'm going to go to see my friend Jay Orange. He's over in Q. So now we've zoomed to our destination location, and a route is generated across campus here. So we're starting on the 3rd floor, and I know the connection speed might not be great, so I won't move it too much. But we start on the 3rd floor of M, come down to the stairwell here in the middle, across to building Q, and take the outside stairwell up to Jay's office here on the 3rd floor. And so with this new JavaScript API, we have ability to filter 3D content, so we can just show the floors of interest that we need to see, or the buildings of interest. So pretty powerful. And you can see here there's a summary of the walking time at about I think it's about a 5 kilometer or 3 mile an hour walking speed, as well as the distance between those two locations. So if we want to get an elevator, we can just click a button here. It'll recalculate the route using a different restriction. And now we have an elevator only route if you have mobility restrictions. So you can see, again, coming down the elevator shaft in building M, coming over to Q, and now going up a different path to get to Jay's office here. So very powerful application and very customizable. So what we can do is we can add additional slides for operational views you may want to share. So in this case, we have services that tell us what office is occupied. So we can get kind of a space management view of our campus at a click. And so you can add any number of slides you want for your campus viewer, for example, an evacuation plan or meeting areas or parking map or visitor points of interest, that type of thing. It's really customizable and extensible. So let's go back to the deck and go with a question for the audience. So I'll give it 30 seconds or so. Okay. So moving on, transitioning to a slightly different use case, we have major events at Esri several times a year, our biggest one being our user conference in July. And so we wanted to use these same workflows to create the maps for our Esri app, our events app. And that includes embedded locations and being able to find sessions that you're signed up for in your schedule. And so in our previous example where we were looking at occupants, now we want to kind of switch over a little bit and look at schedules. So we want to know what's happening in any one of the presentation rooms. So instead of using an employee table, now we have an events table. And so a kind of a different skin for the same application, we just swap in a different service for our events. And so now I'm going to go to the UC version of the Campus Viewer application. And now we can actually search for events. And let me do a, let's search for GeoComm. So GeoComm was at the user conference, had a booth on the expo floor. And we can click on the company name there and see exactly where their booth was located. So this is very valuable for getting kind of awareness of where exhibitors are and where different tech workshops are happening. If we do a different search here, let me search for an event. So let's see, emergency call taking and dispatch using GIS. We can now find this session. And let's say we have to route, and you can see here it's taking some information from this service that tells us the start and end time for that session in that room. So I want to route from here to, let's say, CityWorks is one of the another vendor booth downstairs. We can now calculate a path between these two locations and then follow it. So you can see the convention center is a large building. And so it's almost 7 minutes to get down to the booth. So if you have a meeting, kind of plan ahead, that's half a kilometer away. So we can now strip away the third floor and see the pathway down the escalator over to CityWorks. We could change to an elevator similar to the other application and see the different path, slightly different path that we take, as well as the travel time. So one other example I wanted to show here is we have, from a dispatch perspective, I guess, this demo was put together for by the App Prototype Lab at Esri, and it uses scene layers for San Diego in combination with GeoEvent Server to plot the 3D locations of 911 calls that are coming in. So I'll go back here, and you can see this is running live right now. And actually, let me just reload it just to show you. So what we have is a GeoEvent server. It's serving out call locations, and coming along with the call locations are kind of uncertainty spheres. So we can look at the legend for that. And essentially it's taking the X, Y, and Z uncertainty and creating a kind of confidence sphere around each call location. So this is important. Let me just go back here. We can see our calls coming in. We can click on one of the dispatched items. And if we zoom in, you can see this uncertainty sphere and approximately where that call is coming from. So this information is coming from the request. It's being plotted on the map in 3D along with that uncertainty information. And so you can imagine from a dispatching perspective how powerful it would be to click on the building and show the actual floor plan, the 3D interior floor plan of that building, and select out those floors that intersect with those confidence spheres. And then calculate a route from the police or fire station, which we have also in the map, to those locations automatically. So let me go back to, final sample. We actually took all this indoor data that we're developing for our 3D apps, and as I said, once you have 3D, it's very easy to go 2D. So everything gets flattened out, and we can actually publish these out as a mobile map package that gets hosted on your portal or ArcGIS Online. And this web app, or this mobile app rather, downloads the mobile map package, and within it contains all the employee information, space information, the network itself, so that you can calculate routes between buildings just as you do in the 3D app, in the 2D app in your pocket. Again, showing you kind of step-by-step directions. So that was a kind of a quick tour of some of the 3D and indoor mapping work that me and my colleagues are working on here at Esri. And it's a really exciting topic, and so we'll be releasing some of these new apps and capabilities coming in 2018. But I wanted to hand it off now to Britt Bromley for some other wrap-up information here.
Great, thanks, Craig. So we do have a few items here I want to cover before we wrap up the webinar. And first, I want to hope that everyone found the presentations from John and Craig very informative, and and hopefully gets you thinking about what you can do with 3D in our world today, and using the ArcGIS platform. A couple items. Today's recording this webinar is being recorded, and it will be posted on our Esri website within a couple multiple days here, 3 or 2 days. And then the presenter's information will also be provided at that point. So if you would like to reach out to them directly about questions, feel free to do that. Also want to mention that the FCC ruling on location accuracy and indoor routing, that document has been posted on the handouts on the what you're viewing for this webinar. If you don't see that, we will also be providing a link to that paper on a follow-up email to all the attendees of this webinar. We'd also like to make you aware that Esri has some special licensing programs to assist public agencies. And these programs are really designed to support small agencies and the unique workflows that the public safety markets see, such as shift workers or surge demands result of an event. An event could be a planned event, it could be an unevent planned, like Irma, hurricanes, and things like that. So won't go into a lot of details about the specific of these programs, but please reach out to your account representative to discuss this in more detail. And if you don't happen to know who that person is, don't hesitate to reach out to Mike King or myself, and we'll make sure to make some introductions and make sure you're supported with your questions. So then Craig, if you can just move to that next slide. So we did receive some questions throughout the webinar, and thank you very much for the questions. Won't be able to address them all right now and cover them all, but we will definitely follow up with all questions that were submitted following this webinar. A couple of things, a couple quick questions, and I think these are really going to direct these to Craig. First of all, there was one question that came through as what Esri feature class templates are available to create building complex structures and spaces. I don't know if that's something you can comment on. Craig, did you hear that?
Yeah, sorry.
No problem.
So yeah, we're working on a new schema essentially for indoor, ArcGIS Indoors information model. And this is going to have feature templates, data loaders, basically containers in a very flat data model structure to hold all the kind of indoor information, including, textured building facades, multiple kind of procedural rules for different representations. So we're working on templates essentially and a schema that's dedicated to indoors.
Perfect. Thanks.
But it's going to be released in 2018.
Okay. And Craig, stay online here because I have one more question for you. And I think it's a quick one. I think you've kind of answered it, but you showed the indoor route map, 3D mapping and routing for the San Diego Convention Center for the UC. Yes. And is the plan that to be available to users, attendees for 2018?
Yeah, so we're working on some additional capabilities. That map that I showed was shown at the demo island of the 3D island this year. It wasn't, I guess, widely marketed or publicized, but we're working on an update for this coming year that will have some additional capabilities as well as a kind of companion mobile application. So yeah, we're working on things for UC, and we're hoping to get kind of indoor Blue Dot, which we were testing this last year using Apple Venue survey, get some indoor location for our attendees. That was the #1 request from the events app was, having maps is great, but, where's the Blue Dot? So we heard the requests and we're working on that.
Perfect. Thank you. Appreciate it. So again, there's some additional questions. We'll follow up with those questions following the webinar. And, should go without saying, if you have additional questions that maybe you think about later today, next week, maybe review the recording of this webinar next week with some colleagues, and you have additional questions, don't hesitate to reach out to us. Again, you'll have the contact information for John and Craig, and you have Mike's information. So please reach out to us and let us help us out with any questions you might have. In 2018, more webinars on the way. So specific topics and dates will be shared with all the audience and with others in the upcoming months. So look forward to another series of great webinars in 2018. And lastly, I just want to say, Mike King and I will be at IACP, which starts this Sunday in the great city of Philadelphia. So if anybody on this webinar happens to be attending, or if you have colleagues that are attending, please reach out to us or stop at our booth in Philadelphia, and we'd love to chat with you and learn a little about what you're doing. If you need support on things, we can definitely do that at the conference. So we look forward to seeing anybody who might be attending IACP. And I guess just say really finally, I want to say a big thanks to John Brzezowski and Craig McCabe for presenting, and I'd like also to thank all those who attended today's webinar. With that said, everybody have a great day.